There we are. We are back. We are back live. Better than ever. All of that fun stuff. Woo! Excitement fills the air. Such a different feeling being in here with no people and just talking into the nether space, or I don't even know what I'm saying anymore. But regardless, giving people an opportunity to get into the live stream. For you guys that are here right now, I'm going to have something that you're going to start off with immediately. I'm going to have you sign in to a quizzes. Yes. I have a quizzes lined up that is going to deep dive into your knowledge of graphing polynomials, something that we started on Monday. Now, this quizzes that we are about to partake in is a practice quizzes. I'm not expecting perfection. In fact, with this quizzes, I am anticipating some trouble that you may have with some of the problems, considering the fact that you haven't had the full lesson on all this stuff just yet, but I want to see where you're at. I want to see what you can do with the information that we started on Monday. Now, I can see that there's only roughly about 5 or 6 people here so far, but I'm going to give people an opportunity to kind of get in here. So what I'm doing is I'm duplicating my screen, and I'm going to write the code on the board, because obviously there's a giant glare on the number, which you cannot see. And I'm also going to type it into the chat as well. But the number that y'all are going to need, I already miswrote it, is 824 002. 824. I'm going to type it into the chat in a moment. 824 002. There's that code right there. So, as you guys are coming into this live stream, I would like you to sign into this quizzes, and I'm going to get it started in a few minutes, obviously waiting for people to kind of join in on this thing. Now, after said quizzes, there are going to be some select problems from it that I would like to review with you. And then we will wrap up class with some, I don't want to say declarative, I want to say some informational notes that I'm going to need you to copy down, of course. When this class period is over at approximately 10:28, there will be a Google Classroom assignment made live to you. I've scheduled it to be released at 10:28. And that Google Classroom assignment is going to be a homework that you guys are going to complete for me. And it will be due on Monday. And we'll get this thing done. It'd be fantastic. Now, again, for you guys joining the quizzes, joinmyquiz.com. The code is 824-002. I've typed it into the chat as well. I'm expecting people to join. Now, when you join the quizzes, people always ask, like, do I have to click start? Well, no, technically, I click start, but you click whatever you need to click in order to get into this thing right here. So if you click start, it won't start for you just yet. But so far, I only have 2 people in there. 2 people in there, and it looks like there's 7 people in the chat, so I don't know what's going on there. There's a lot more people in this class than just the people in the chat right now. Here come more people signing in. Now, as you are awaiting this quizzes to start, I am going to also suggest that you have your notebooks out, of course. The notebooks as a reference that you can use for a lot of these problems. And again, I'm going to be very, very clear about what I expect from this quizzes. I do expect you to try your best. It is just a practice quizzes. I only got 4 signed in so far. It is just a practice quizzes. This one is a little more difficult than some of the other ones that you have seen. It's going to be all about graphing polynomials. But a lot of this information, the way that they word it, may be like, what the heck are they saying? Kind of situation. But again, I want to see where you guys are at. Now, again, I'm not expecting perfection from this. I'm not expecting perfection, but I am expecting for you to try your best on this quizzes. Again, the code, for those of you that are joining us, is at the top of the screen right here, 824002. I have also typed it into the chat, 824002, so that you can join. I only have 4 people joining, even though there are 9 people in the chat. That's weird. I expected more. Now, even after I click start, that code will appear at the top of the screen in white. So if I click start and you haven't joined yet, you need to join that thing so that we can get some good results with this. How many kids? I hear more popping noises behind me. I'm just going to check something real quick. Because the last I checked in period 3A, I had over 20 students, 21 students in this class. Yes. Yet only 9 have showed up to a live stream of a lesson. That makes me sad on so many levels. Anyway, we're going to get this thing started in 1 more minute. Like I said, the code is in the chat right now, 824002. And I wrote it up there. I'm going to go over and click start. Now, I'm going to give you the heads up. The other class tried this quizzes already. I told them beforehand it was difficult. I'm giving you the heads up. It is difficult. It is a practice. I am not expecting good numbers per se. I am expecting to see where you guys are at. That's what I want to see. But I want to see if you can beat their score. They scored roughly 33% on average. 33%. They got a third correct. That's okay. Multiple choice quizzes, those are kind of tough. Let's see what you can do. Again, if you haven't joined, the code, once I click start, will pop up at the top of the screen in white. Click, and we'll get this thing going. Again, those who are going to be possibly joining late, I'm going to type some additional information into the chat. You go to join my quiz. Code is 824002. 824002. Let's get them going. You can join even if the thing has already started. Probably just a few more minutes, just a couple more minutes, and then we will wrap this up. And again, I would like to see some of these problems that are definitely more red than others. There we go. Excellent. I mean, like I said, comparatively to the class from yesterday, yeah, you guys did considerably better. I mean, keeping in mind that you guys had that lesson on Monday and they had that lesson Wednesday of last week, which I did that on purpose just because I wanted to see what they could do with it. But you guys did do considerably better. There are some questions that we definitely will take a look at, the ones that are marked in red, and maybe some of the ones that are marked in yellow as well. So let's take a look. Now, on the quizzes, I purposely changed some of the settings on the quizzes so that you could see whether or not you got the question right or wrong, and that you could see the questions at the end, I believe, to review. So the questions that I'm going to be showing you in a few moments, you can easily take a look at on your own screen. But I'm going to do my best to visibly display that here. Click. Let's see. I'll have to bring up this as well in order to get a better view on things. Reports. This thing. View it. There it is. All right. So let's start with something like number 7. Excellent. Let me click up to number 7. There we go. Good. Now, hopefully you can see that a little bit. I'm going to come up to see exactly what that looks like. But this is number 7, which they asked which of the following could be the equation of that particular graph. Now, obviously, the giant glare in the middle is not helping too much, but you can see number 7 on your quizzes as long as you didn't close it out. But let's talk about this equation. This equation, based on the end behavior, must have a degree that is odd. It must have a degree that is odd. How do I know that? Just by looking at it. Just by looking at the graph. How do I know that? Well, if you look at the end behavior, the ends of the graph, one is going up towards infinity, the other is going down towards negative infinity. They are going in opposite directions. Since they are going in opposite directions, the degree of this polynomial must be an odd number. Again, the degree of the polynomial being the largest exponent. So right off the bat, these two equations, with the x squared being the largest exponent, these two equations cannot be the answer. It has to be one of these two. Now, being that you guys are at home for the most part, and obviously even if you were in class, you still had your Chromebooks, you could still have the opportunity to use those graphing calculators. Now, being that you have a graphing calculator on your computer, you could potentially type that in. You could type that in to the y equals key. And if you were able to type that into the y equals key, you could visibly see which graph it was supposed to be. Now, knowing what the degree is allows you to minimize your choices. Now it's down to just two choices. It's either the x cubed or the x cubed. Now, if I were to actually type these things into my graphing calculator, which apparently, there it is. It's frozen for half a second. Zoom, zoom, zoom. There we go, right there. Boom. I'll close that out. Let me flip back here and get the equation. One of the equations was x cubed plus 6x squared plus 9x. Flipping that back, you can see that. And if I were to visibly see what's going on here, well, that's not it. It definitely is not it. Perhaps it's the other one where it was a minus 6x squared. There's the one. There's the one. Click. Just for the sake of argument, if I were to look at this graph, which, by the way, yes, if I showed the answer to 2, there's the answer right there. What did you guys pick? Most of you picked the other x cubed. Okay, all right. Picking the other x cubed was an interesting idea, but obviously not. But looking at this particular graph, just for the sake of argument, this third degree polynomial, just analyzing the graph a little bit deeper, it only hits the x-axis twice, just for the, again, the sake of argument. It looks like there's a turning point that's occurring right on an x-intercept, which is nice. So there's an x-intercept, there's the other x-intercept. There's only two, which fits the definition. Because if the degree of polynomial is 3, then you can have at most 3 real solutions. But if you include complex and repeated, which that one is repeated, you would have 3. I love it so much. Let's take a look at a different problem. Let's see here. Let's take a look at number 11. Excellent. Here, 11. Boom. It says to write a polynomial of least degree that has zeros at 1, -1, and 0. Okay. So it has 3 factors. It has 3 factors. The factors of this particular problem, or I'm sorry, not factors, zeros. The zeros of this particular problem are 1, -1, and 0. There are 3 zeros of this problem. It just so happens that the numerical value of 0 is a 0. It's a weird phrasing, I know. But if those are the zeros, then these, in order, should be the factors. If you have x, excuse me, if you have x equals 0 as a solution to your problem, then that must mean that x itself is a factor, x plus 0, if you wanted to write it like that. And then all we would have to do is multiply these things together. Well, if you multiply these together, you get x squared minus 1, still being multiplied by x. Distribute, you end up with x cubed minus x, which is that answer there. Being able to transition from the zeros of the function to the factors of the function and then multiplying them back together is something that it basically culminates a lot of stuff that we've been doing from the beginning of the year, just for the sake of argument. Let's see here. Go away that thing. There we go. Let's see what we got coming up next. Let's see. Here we go. Number 12. Excellent. Now the notation for number 12. Actually, let me see what y'all picked for number 12. What did most of you pick for number 12? Most of you picked this option. Negative, negative. Positive, positive. Interesting. Okay. Got it. Okay. Most of you picked this one right here. This is what most of you picked. Now, the notation is a little difficult to see. I'm on number 12, by the way, for the sake of argument. If you're on your quizzes and you can go to number 12 and open that up, you can see that that's the one that most of you picked. But the degree of this polynomial is 3, meaning it is an odd degree. And since it is an odd degree, the end behavior must go in odd opposite directions. The leading coefficient, which is the number in front of the variable with the largest degree, is a -1. Meaning that if I were to sketch the end behavior of this graph, the end behavior would look something like that. To the right, it's going down, and to the left, it's going up. Meaning, as x goes to the right, the function is headed down, and as x goes to the left, the function is going up. That's why it was actually that solution right there. And again, I know the notation is not really that easy to type out, which is why we typically write out the notation for that. Again, I'm not a huge fan of the notation for end behavior, but it does come in handy for certain things, especially if you have to do stuff like that on an assessment. Hint, just saying. Anyway, let's see what else we got. Just a few more problems to go over before I finish up with a little bit of notes at the end. Let's see here. After number 12, looks like 14. 14. What did y'all pick? Most of you picked the first one. Excellent. Okay, let's talk about 14. Now, 14 was one of those things that, again, I'm going to talk about in the notes today. I see what most of you picked, and most of you normally might have been correct, but we really have to analyze this graph. First, look at the end behavior of this graph. The end behavior of this graph, they're both going up, meaning that the degree of this polynomial, the degree of this image of this graph, I'm going to try to move that picture so you can see it a little bit better. But the image of this graph, I don't know if that was better or worse. The degree is even. The degree is even. It has to be even. But I only visibly see 3 solutions. I only visibly see 3 x-intercepts, which most of you picked this one, which under normal circumstances you would be correct. However, this is one of those things that I haven't actually, written down yet. I've talked about it, but I haven't written it down yet. This graph has a repeated solution. It has a repeated solution at the turning point. The turning point lies directly on the x-axis, and because of that, by definition that I'm going to write down in our notes today, it has a repeated solution. And because it has a repeated solution, it has a repeated factor. That's what this thing actually does. So you are correct in saying x plus 3 and x minus 2 and x minus 5. You're correct in saying that, but because the 5 repeats, there is a repeated x minus 5. Thus, the answer was right there. Oh, what a tricky, tricky problem. Again, I warned you guys at the beginning of this that this quizzes would be a bit more difficult because I hadn't shown you everything just yet. That is okay. We're learning. We're moving forward. We're high-fiving each other at a social distance. Let's do one more before I jump to my notes. Let's do one more. Let's see here. No, I don't want to do that one. Oh, that's a fun one. Yeah, let's do this one. I want to do 20. Yes, let's do 20. I'll wrap up with 20 here. Which of the following best suits the statement for the graph shown? The statement is, this polynomial will have a degree 3. And then the answer is sometimes, always, never, or cannot be determined. Well, let's talk about a few things. First of all, the end behavior. The end behavior of this problem is, well, it's going in opposite directions, which means the degree does have to be odd. So far, so good. They're saying, hey, it's a degree of 3. And I'm saying, well, maybe, because it's odd. Now, you may not be able to see this because of the glare. So like I said, I think this is number 20 on there. So looking at the particular quizzes, there's a turning point. There's a second turning point. There's a third turning point. And there's a fourth turning point. By definition, if the degree is n, then at most it would have n minus 1 turning points. I count 1, 2, 3. I count 4 turning points. There is no possible way this is a third degree polynomial. There's no possible way. It can't happen. It can't happen. As a result, they're saying, hey, this polynomial has a degree of 3. And I'm saying, sorry, never. It can't be a degree of 3 because of the turning points. Ha 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 ha. Okay. Ladies and gentlemen, for those of you that are with me still, with the time that I have left, because I have a little less than 20 minutes, I'm going to need those notebooks out and open. I would like to write down some information to wrap up today. Let's see what I got here for you. Okay. I'm going to switch my camera over in a moment. Wow. Zoom it back out. Yow. And let's see what we got. Today is December 2nd. And I'm going to call this Graphing Poly Continued. There we go. Graphing Polynomials Continued. I just abbreviated continued. Phenomenal. Anyway, a couple of statements here that we talked about during the quizzes, but I want to make sure that you got written down. If a turning point occurs on the x-axis, then, I'll pause right there for a moment. But if a turning point occurs directly on top of the x-axis, then something happens. sorry. Then there exists a repeated zero. You have to be aware of this. If a turning point is going to occur directly on top of the x-axis, then you have a repeated zero. Now, what's really interesting about that, is the fact that I'm going to type something into my graphing calculator now so that you can see it. There it is. Good. Let me zoom in here. Technically, what you have in front of you right now, it doesn't exactly look like a turning point. It's almost like it's wanted to be a turning point, and then it just kept going. I'll zoom in there. Hold on. Zoom in. I'll come back to the notes in a moment. I just want to show you this visual. There we go. Look at this graph. Boom, boom. It's like it wanted to be a turning point, but then it kept going. Oh, still counts. Still counts as a repeated zero. Now, how many times does it repeat? That remains to be seen. We'll talk about that another time. But if a turning point occurs on the x-axis, then there exists a repeated zero. Trying to bring up the chat so I can see it just in case you guys have questions in there. There we go. Furthermore, in factored form, a repeated zero could be expressed with an exponent. And I'll show you what I mean in a moment. But if you had an equation that was written in factored form, meaning you had all of the parentheses, x minus 1, x plus 5, whatever, doesn't matter. You could express it with an exponent. And what I mean by that is this. Let's just say, for instance, that we had a problem where you were given the following zeros. You were given the zeros of 2, 1, 1, and -3. Now, those are the zeros of the function. They are not the factors of the function. The factors would be x minus 2, x minus 1, x minus 1, and x plus 3. Now, those would be the factors. Now, we're not quite there just yet because, again, that doesn't really fit what I just said. In factored form, a repeated zero could be expressed with an exponent. And what that means is this. Well, this x minus 1 is technically a repeated factor. So the way that I could write this is x minus 2, x minus 1 with a square, and an x plus 3. That's just another way that you could potentially write the answer to this problem. Now, there is one problem from the quizzes that I would like to do with you right now. There is one that I skipped purposefully when we were reviewing it. I'm going to come back to it. But this is one way you could deal with repeated zeros. Now, yes, if you had to multiply all this junk out, you'd multiply all this junk out. That's besides the point right now. But what does matter is that you could condense things with repeated zeros. Let me show you what I mean. On the quizzes, I forget which problem this was. Let's see here. Come on, you. Which one were you? There it is. It was number 17. Oh no. Number 17. Now, if you read number 17, I have it up on the board right now, but if you read number 17 on the quizzes, it says to select the polynomial whose zeros and degrees are given. What do they give you? They give you a -5 as a 0, but it says a multiplicity of 3. What does that mean? Now, again, this is something that I didn't teach yet. I'm teaching it literally right now. But if it has a multiplicity of 3, that means that it repeats 3 times. 9 is a 0 and it repeats twice. -2 is a 0 and 4 is a 0. And the degree is 7. So, hold on. Let's write some of this stuff down. First of all, the zeros that they give you. -5. It's said with a multiplicity of 3, so I'm just going to say it repeats 3 times. 9 was a 0, but that thing repeated twice. They also said -2 was a 0 and +4 was a 0. Then they said that the degree of this thing had to be 7, meaning a 7th degree polynomial, the largest exponent being a 7. Look at the way they gave you the choices. They gave you the choices in that factored form that I was referring to. Well, let's see what it would look like. -5 is a 0. And as you guys did pretty well with, if -5 is a 0, that must mean that x plus 5 is the factor. Yes, yes, yes. But it repeats 3 times. Meaning that I could write that with an exponent of 3. It's x plus 5 cubed. I mean, if you wanted to, you could write it out x plus 5, x plus 5, x plus 5, but you don't have to. You could write it out just like that. Well, what about 9? 9 would be written as x minus 9, yes, but it repeats twice. I'm going to put a little square there because it would be x minus 9 times x minus 9. What about the -2? The -2, it only happens once, so I'll write x plus 2. And the +4, I'm going to write x minus 4. So what about the degree of 7? Well, technically, we don't have to worry about the degree of 7 because if you look where I'm pointing right now, if you were to multiply out x plus 5 times x plus 5 times x plus 5, if you were to actually multiply that out, you would end up with an x cubed. Right here, you'd end up with an x squared. Here you get an x, here you get an x. So this is really x cubed. Then with the x squared, now we have 5. Then with the x plus 2, we have 6. And with the x minus 4, we have 7. That's a 7th degree polynomial. That really is actually x to the 7th power. And if you go to the quizzes and click show answer, you can see the one that is green is exactly the one that I just wrote down. Amazing. So listen, here's what's going to happen. In a little less than 10 minutes, there will be a Google Classroom assignment that is made live to you. That assignment is due Monday. Yes, it's a homework. I talk about it in the instructions. I'm not grading it on correctness. I want to see what you can do. There are some graphing problems there. There are some problems trying to get you to identify certain characteristics and attributes of polynomials. The directions are all there. You'll see it. But I'm assigning it. It'll literally be live in the next 10 minutes. I scheduled it to go at like 10:28. I want you to do that. Try your best. See what you can do. We are going to be wrapping up this chapter very soon. And there will be a major assessment before the end of next week. Let me repeat that. We are wrapping up this chapter soon. And there will be a major assessment before the end of next week. Want us all to be on the same page. Anywho's, I'm going to end just a few minutes early. The time is 10:22. Technically, it's only about another 4 minutes or so. But I'm going to end it here. Now, of course, if you have any questions, email me. Otherwise, that's it for me today. You all have a wonderful morning. It's 10:20. Some people are still waking up right now. I've been up since about 4. But that's me. Anyway, have fun. Take your stuff from underneath your desks. Go, go, go. Don't be late to your next class. Bye-bye, bye-bye, bye-bye. Have fun, have fun. Bye-bye, bye-bye. Again, remember, in the next 10 minutes or so, less than 10 minutes, that assignment will be live. So be ready for it. Yay. Okay, I'm leaving. Bye-bye, bye-bye.